Hello everyone, this is Dr. J. Anita Hepsiba, Department of Chemistry, Dr. SNS Rajalakshmi College of Arts and Science, Coimbatore. In this video, we will be discussing about the treatment methods which are available for textile effluent. So instead of the industry, particularly the textile industry, discharging the textile effluent as such into the environment, some of the treatment methods are suggested so they can be followed and then they can be discharged. There are three stages of wastewater treatment. The first stage is primary treatment, secondary treatment, and tertiary treatment. So, this primary treatment is based on the removal of suspended solids, secondary and tertiary treatment based on undissolved solids, and we will look into these three stages in detail in the coming slides. The first step is the primary treatment, which focuses on removing large and visible impurities. The first method is screening. It is similar to that of filtering, right? So you have large filters, that is, we call them as grit chambers, and the size of the mesh in the screen varies. Accordingly, the different types of impurities, sizes of impurities are also removed. The screening will help us to remove fibers, threads, debris, any leafy particles, woody particles, etc. from the textile effluent. After the screening process is over, the effluent, now we call that as an influent because it is taken into a process, right? So after grit chamber, it is then taken into a sedimentation tank. Okay, now in the sedimentation tank, the principle followed is the force of gravity. According to the force of gravity, the solids settle down at the bottom. We just leave the liquor undisturbed for overnight, and the solids settle down at the bottom, and we can just decant the textile effluent, that is the liquor, and then it can be sent out, taken for the next process. The third one is called as the equalization tank. This equalization tank is used to balance the pH of the effluent. Okay, if it is more alkaline, it is neutralized with an acid. If it is more acidic, it is neutralized with an alkali, and hence the output water is at neutral pH. So here we have removed the suspended solids, that is fibers, threads and debris, that is small and minute particles, by screening, and in sedimentation some more larger particles are removed, and in equalization tank the pH is balanced. The next process is the secondary treatment. It is also called as biological treatment. Herein we break down the organic matter by using bacteria. There are again three major methods used. First one is the activated sludge process. Here we use microorganisms to break down the organic waste matter which is present in the effluent. What is the organic waste matter which is present in the effluent? What is the possibility for it? Any debris which is removed from the fabric in terms of scouring, bleaching, etc. They are considered to be organic, and they can be removed by means of suitable bacteria, and the process, the waste which comes out, we call it as sludge. That's why we call this as an activated sludge process. The next one is trickling filter. You can imagine this like an umbrella. Okay, the umbrella, the wastewater passes through the central middle uh, tunnel, and it flows through like an umbrella. When it flows like an umbrella, it gets oxygenated, and due to the presence of the more amount of oxygen, the water gets treated, and when it rises up also, it rises through a layer of bed of stones, so that any impurities is retained. So we call this as trickling filter. trickling filter. So it filters and then trickles. So it is again a secondary treatment, which is an aerobic method. And we also have anaerobic and aerobic reactors, which depend on the level of oxygen which is needed for the microorganism, which is used in the secondary treatment. So if the microorganism is anaerobic, you can make use of an anaerobic reactor. If the microorganism requires surplus amount of oxygen, we can make use of an aerobic reactor. So here we have in the slide we can see the sewage which is entering into the aeration tank, and then the secondary clarifier, and then comes out for tertiary treatment. So here in the aeration tank, it is properly aerated, that is oxygenated, so that purification takes place. The next method is tertiary treatment. Here we have chemical coagulation and flocculation. So chemical coagulation is adding a coagulant. A coagulant in the sense it can be a potash alum, chrome alum, etc. What is the purpose of a coagulant? It just makes the smaller particles coarser in size and makes them to sediment very easier. So coagulation can also be accompanied along with sedimentation while purifying drinking water and all. But here it is a chemical coagulation and flocculant. Okay, so you make it as a easily removable material and then it can be removed. Then membrane filtration. Membrane filtration, we can make use of ultrafiltration and reverse osmosis. So here reverse osmosis, the movement of solute particles. Okay, usually solvent moves, but here in osmosis the solute moves from the constant dilute side to the concentrated side, so the dilute side becomes the concentrated side to the dilute side, so that the concentrated solution becomes less what else, lesser content of the dissolved substances now. So this is made more effective by ultrafiltration too, that is by varying the filter size by micrometer. Tertiary treatment also includes activated carbon adsorption. This activated carbon adsorption ensures the removal of color and odor. We certainly have colored substances also in textile effluent. So this color can be removed by activated charcoal. It's a very good adsorbent. And also odor can also be removed. Advanced oxidation process, that is we call it as AOPs, they can be achieved by using ozone and UV treatment for breaking down the chemicals which are present. It is actually the process of using activated chlorine, that is bleaching powder, in a drinking water process. So here also we can use UV treatment and also ozone for breaking down harmful chemicals which are present in the textile effluent, and then it can be made somewhat harmless. Apart from the primary, secondary and tertiary methods, many industrial units are also concentrating on ZLD method. What is this ZLD method? Zero liquid discharge. Instead of simply disposing all the effluent outside the industrial unit, we just make use of reuse methodology. That is, the wastewater which comes out is reused for other purposes, and it minimizes the level of water which is being discharged outside. So here you see the slide, that is fresh water is given into the wastewater producing, that is the unit, and then the wastewater which comes out. Here you have a plant where zero liquid discharge treatment plant. So here the treated fresh water, that is the wastewater is treated, and the treated fresh water, it is taken for reuse into the textile unit again, and then the chemicals which are remaining, that is taken for chemicals for reuse. So the disposal is nullified, and we call this as zero liquid discharge. So these are some of the sustainable methods which are now being practiced in industrial units. Thank you.